So we'll quickly go over what the app does before we start making the app to get a clearer understanding of the functionality and the layout of the app before we actually build it. So this is where the user lands up when they open the app. We have two text boxes where they enter the app ID and the channel name. You can obtain the app ID from the Agora dashboard. Whenever you create a project, you will be given an app ID for that particular project. The channel name can be anything you want. Once you click Start Call, you enter that channel and you'll see this kind of a screen. If there's multiple people in the call already, we have a sliding view where we can toggle between users, and we can click on a user to change the feed from the main feed to that user. We also have these buttons to mute our own local video and audio. Also a button to go back by ending the call. We come back here, we'll be building it next. We have a blog post on Medium where it goes into building a React Native video calling app using the Agora SDK, and it goes through the process of making an account, getting an app ID, and using it to run an app, which is available on GitHub. You can check it here, or there'll be a link in the description. I referenced this article to pick code up where I think it's simple enough to understand. For example, this permission.js file basically gets permission on an Android platform for camera and audio. So we'll quickly pick code from here and we'll not waste time typing it out. So to save time on installing dependencies, I've already gone ahead and initialized the React Native app and the required 3 libraries that we will be using. So the first one is the React Native Agora SDK. It's the 2.9.0 Alpha 1 release. Then we're using router flux for the navigation between the two screens that we just talked about. And we're using vector icons for our buttons. Basically, you have to install npm or use yarn. You'll get some messages, and once that's done, it'll give you a success message. Then we do React Native link. This will link the native liabilities to our current project. Once you've gone ahead and linked both the Agora SDK and the vector icons, you'd be good to proceed with the tutorial. This is where we start. This is our index.js, where you basically register your component for your main activity, which will be the root component, which will be responsible for moving us between the main activity, that's the login screen, to the video screen during a video call. And we'll import the necessary things, register component into the app registry, and we import name from app name. This is stored in our app.json. This is what my app.json looks like. You can have anything else for the name or the display name. So we'll start by making a permission.js component, and we'll quickly grab the code from here, and we'll go ahead and copy that, and we'll paste it into a permission.js file. I've disabled some lint styling that would avoid an ESLint errors. We're using a function to request for permissions on Android platform for camera and audio. So if we get those permissions, we console.log, and if we don't, we also console.log the error. Then we move on the rest of the code. We call this permission function during the launch of our application. So the next component we'll create is called the router, which will be responsible for getting us to different screens in the app. So I'll go ahead and disable prettier, then I'll import router scene and action constant. From the React Native router flux. I'll also import React from the React. We will import the two components that we'll make in the future called video from video. And then from video, then we will have home from home, like so. So we'll begin this component by getting a constant called router component. And go ahead and define something called a router. People who have used router flux can forward this a bit. And we'll define another scene inside this called home. So we give it a key called home. bring this to the component called home that we just imported. We'll give it a title like Agora Video Call. We'll give it an initial and give it a type called action const.reset. We'll add another scene for our video called screen called video component. We'll give this a title, maybe video feed. Give it a type in const. And we'll hide the navigation module. So we'll type hide navbar equals true. Yeah, that's about it. So we go ahead and export our router component. For our first component, we create our home.js file, which will be the first component the user sees. It's responsible for getting us the app ID and the channel names. So we'll import the basic things, and we start by creating our class-based component called home. We'll do extends component and define the constructor superprops. Then we'll initialize the state. It will have two things, the app ID, and it should have your app ID. So something like 1, 2, 3, 4, 5, 6. You should get this from the Agora dashboard and have something called channel name. So we get something like test. Then we'll go ahead and call this function that we just defined in the previous file. We'll define a promise, do console.log event to see if everything's going fine. Do something like requested. Then we'll start by creating something to handle the submit action. This will be responsible for getting the data and passing it to the next screen. Or rather setting it to our state, which goes over to the next screen. So we'll have a variable called PID. With this .state.pid, we'll have another variable called channel name. And we'll set that to this .state.channel name. We'll check if app ID not equals empty string and channel name not equal to empty string. We'll do actions.video. And we'll pass in app ID as well as the channel name. So what this does is it takes us to the video scene, but the data we'll define a render method. We'll return a few things. So first, we'll return view. And we'll define all these styles towards the very end. So we'll do styles equals styles.container, where all 4 components go. Inside that, we'll create text field. We can set this as the app ID. We will go ahead and copy that. We'll make the same for channel name. We'll make the same for channel name. We'll define an onChange text event and set that to our function. We'll pass the app ID. So this will change our state whenever our app ID is changed, and we'll have the value set. This should be good. The same text input. That defines the two text boxes and two text labels. So we'll go ahead and we'll create a button. We'll go ahead and create a view, give it some style called button container. Inside that, we'll create a touchable opacity. We'll tie our onSubmit function to the onPress event. Give it a title, let's say start call. We'll have to add some text inside it. Just give an inline style. We'll call start call. Yeah, that looks good. So we'll quickly fix this one. Step, all of this should be inside the class base component. So now I will define our styling, and instead of typing everything again, I'll just copy and paste this here. We're creating a style sheet for our components. One last thing before we wrap this up. We'll export default home. That's all for our home component. Next component that we'll be working on will be the video.js for the video component, and I'll go ahead and import things that we need. We'll be using the Agora SDK here. We'll quickly initialize a native module like so, and we'll define a few constants. For our default profiles for audio and video, so we'll go ahead and take this from the Agora object. These will be the default for our stream. So we'll create a class-based component called video and extends component. So we begin by writing the constructor, taking the props, we'll initialize the state. We'll have an array for peer IDs. This will contain all the users that are joining our video call. We will create a UID for the host user. So we'll generate a random number. For the local user who's using the app. We'll have the app ID, which we'll take from the props. And have the channel name. We will have a variable able to store if our video is muted. And one for our audio. We'll have one check if we've joined a call. That's for our state. We'll create a constant called config, and we're configuring the data fields that will be passing on to the RTC engine. You could customize these values based on what your focus is. We have adaptive because we can have different orientations, but for now we'll just be making one view for portrait orientation mode. That's all for our constants. We'll initialize the RTC engine here. So RTC engine dot init, and we pass in the config. Let me create it over here. So this will initialize the engine for us. We'll now go ahead and use component did mount. There's a few things we'll have to take care of, and that's handling events. So the RTC provides events for a lot of things. One of them is user join. So we can do something like our RTC engine dot on user join, like so, and we can get some data that we can use. So we can get the user IDs from the event, and if your ID is not there in the array, that is the user isn't there, we'll add that user to our array by using the spread operator. We have to close some bracket that we missed out. Sorry about that. So basically we're getting a new user, triggering an event, and then we're adding it to our peer IDs to use that. We'll use that later. So next we'll do RTC engine dot on user offline. We'll handle that logic. Remove that user from the array that we have. We'll use one more function called joins channel. success. This triggers when we have successfully joined the channel, so we'll pass it to another callback and we'll set the state once again. And we'll also go ahead on the RTC engine.start preview. So this will start our feed. We also do RTC engine.join channel. This dot state channel name and UID. What we're doing here is before we join the channel, successfully we define the success event. We set the local feed preview and we'll call the RTC engine to finally join the channel with channel names app ID. So this event would on success trigger this event. So we're calling this activates first attempts to join a channel. And then when we get a success, we fire up this event and we start to preview. So once that's done, we'll go ahead and we should also at this point really start engine.enable audio so that we have the audio going. So now that that's done, we'll create functions to toggle audio toggle, video and call and change feeds. So those would look something like this. Toggle audio will take variable called mute and set that from the state like so. When we can do RTC, then .mute local, audio stream now the pass mute, then we will change the state. Like so, this basically becomes the toggle function, then we'll similarly create a toggle video function. We will create another function called endCall to end our call and take us back to the previous screen. RTC engine.destroy will end the call and destroy the engine instance, and we'll do actions.home. This will take us back to home, so next we define a function called peer-click. Again, this function will swap the video's feed, so it's like swapping two variables. So we'll take the peer ID to swap from this .state.peer_IDs. Data, so we'll get what was clicked on, we get the user's peer ID, and so this .state.setState, and we'll use previous state, pass it to this. Pass it to this function where we swap the two users, the current made feed and the users that's clicked on. The made feed user is always on array position 0. That's how we'll build our view logic. When we're building our view, we'll define the 0th element to always be the main feed, and we'll have all other feeds to be inside a scrolling view. Current viewers looks good. Now we'll go ahead and create a video view. This will be our view for the return. So we'll go ahead and create a view, give it some style. I'll just use inline style wherever I can. You could probably define it better in a style sheet, which I'll also show you. So this is the view that wraps everything. We'll use the ternary operators to define our views. So if you have more than one users, that's not including the host user. So we'll have a flex1. We'll have 3/4 of the height being taken up by the main view. So we'll strap 50 from this for the buttons. This will initialize an Agora view. This is where our video feed would sit. We will do flex1. We will define a remote UID. This state.peer ID 0. So this will always be the 0 element. That's how we're building our switch logic mode. Equals 1. We'll have a view style. I mentioned that height by 4 for our scrolling view, and we define a scroll view. Like so here, the horizontal equals true so that we can scroll horizontally. If we change that and a snap to interval dimensions of dot width by 2 equals, so we'll snap after each clip. We have this dot state dot peer IDs, and we'll remove the first element. So we'll do slice 1 dot map. And this is a common way to make lists in React Native. So we'll go ahead and do data. We'll create a touchable opacity so we can fire the peer click event. So we'll do something like, so it's very important for you to pass these values to the Agora view as well as the touchable. the touchable opacity so that we don't run into any issues with view size that we're setting for the video feed, because we can't make sure what the other users' aspect ratios and things like that. We'll pass this to an onPress event called yourClick that we just defined. Then we pass in the data as well as we give it a key. Also give this data so that looks good. We go ahead and define the Agora view inside this and copy paste. Looks good. We need with remote ID, it will be our data, set the mode and key. So that creates a scroll view where we have our touchable opacity and we have our Agora. So we can click on each user and swap those out. So we move on. And we'll see if we have less than one user. We'll also check if we have only one user. On the screen, so we give them the entire screen. When there's 0 users, we'll just leave a message. Looks good. We'll go ahead and do buttons. We'll make the video mute. First, we'll do this at state dot. And this is for our own local feed. And this has to be on top of other things. So we'll define Z order media overlay. And set show local video to true. Looks good. We'll make the button container. making that blue. And we'll define the icon, so mic off and mic. Lastly, on press, we call the function that we define, like so. Looks good. We'll copy that. And we do end call. We make another one for video mute. Looks about right for the style sheet, so I'll go ahead and paste that there, not much to it. And I'll do an export default video. That's our video component. We'll fix these errors. Yeah, change this to data and this to styles. Yeah, it looks good. So that's the video.js component. We'll go over it. We create a UID as random for the local stream. That's a peer ID array. That's channel name app ID that we saw from the previous props. That's video and audio mute. Variable to store those particular values. Before component mount, we check for events, and on user join event, we add them to another array on user offline. We will filter them out of the array. Once success, we set the successful true. We start the engine, we join the channel, and enable the audio. Then to change the video stream from an active user to a secondary user, on click, we call the peer click event. So that basically swaps out the 0th element with the viewer that's clicked. 0th element user will always be the maximized view, always getting 3/4 of the screen. This is where the other users are shown. Present, we refine now another view for just one user where it's taking up the entire screen. Taking up the entire screen, and then we define the buttons. We're defining the styles. We define our own, the local video feed. We return this in our render method. We get the dimensions and set our styles. That's about it for the video.js component. I'll go ahead and demo the app now so you can see what it looks like and how to run it.